which would take waypoints from Google Maps, download those in from PDA, and the car would be able to trace the route that was downloaded to the car by the PDA. An additional bit of functionality of the vehicle was for it to be able to avoid obstacles in its path and resume its course once it has avoided all these obstacles. So that's the introduction. I'll go to the next slide. Where is our presentations? I guess we'll skip over the contents of the presentation and everything makes sense. This is the overview, as I already stated. So let's talk about the specifications of the car. Peak performance was 0 to 32 degrees standard. We want the vehicle to operate at 30 centimeters per second, or about 1 foot per second. The vehicle operates for 1 hour without charging, powered by a 12-volt DC battery. It operates on both concrete and short grass surfaces. The obstacle recognition component of the project, there are 4 acoustic sensors, 2 on the front, 1 on each side, detecting the obstacles and perceived depth. For the avoidance, within 2 meters when we're outdoors, the car will detect an obstacle and begin.
This is with 5 different components, which are the ultrasound sensors, 4 of them, as I mentioned already. We have the PDA, which was developed by Ashley, the GPS and the compass interface with the microprocessor through serial port for the GPS. And originally we had I2C for the compass, but we found a better interface, which was PWM, because it only uses 1 pin, and we found it to be much more convenient to develop for. And of course the platform, which whose wheels are controlled by a pulse width modulator. The platform has 6 wheels, 3 on the right, 3 on the left, which are controlled each by individual pins and can also serve as an external power generator. So our whole system was powered by the platform, 5-volt were supplied by the platform. The only things that were independent of the platform's power are the PDA, and the GPS. And just to review, the PDA is supposed to interact with the microprocessor with Bluetooth and the compass PWM, GPS is serial port. The sensors are just GPIO pins. We talked about the 32-bit microprocessor. The development board for this actually goes into, it has the highest priority out of all the different modes, because when you see an obstacle, no matter what it is, you don't want to listen to anything else. You want to avoid it. So this is what it's going to do. If it's not detecting any obstacles, it will listen to navigation commands. But if it is, it will go into its own things. Navigation commands coming from the PDA, it will stop listening to the PDA and follow the microprocessor controls, which will tell it how to avoid obstacles. In such a sense, right now it's following waypoints given by the navigation point, but since it's detecting an obstacle, it will stop listening to commands. The sensor will be triggered, and it knows what its next waypoint is. Ultimately, ideally, we would want the car to remember its next waypoint, which it can do, and once and its objective after avoiding the obstacle is to get there. These are this is how it will behave. Since this was triggered, it will go to the right, and then these 4 sensors are triggered. It will keep on going until it reaches this waypoint. And now it knows, since all sensors are off, it knows that it can safely listen to navigation commands again. The 4 acoustic sensors interface with, as I said, PWM. They are smart sensors, meaning that they actually can timestamp it's their distance to the data that they get. So they send in a pulse, expect it to come back, and
receive data from either the compass or the GPS. G to receive data from the GPS and L to receive data from the compass. The purpose of the PDA was to send waypoints to the vehicle, also to calculate the trajectory and tell it, the car, after it calculated the correct trajectory angle, whether to go left or right it was pointing in the right direction to the next breakpoint. The GPS sends an NMEA sentence. The PDA will only read the GPGBA sentence, which is defined only by exactly where the vehicle is at that point, rather than consider where it had been previously. And this is the sentence. The car will consider the PDA will consider the left. And on the right, you can export these points to text file, which is displayed on the left. And that is the file that the PDA reads with the waypoints in it.
So this is the chip that we're going to use on the PCB for our Bluetooth communication. The reason we chose this one is because it actually has an on-chip antenna, so there's no need for an external antenna. Unfortunately, as you can see, all of the surface mount pins are on the underside of this, so it made soldering very difficult, which is just one of the issues we ran into with the PCB. Yeah, the second one we ran into actually was with the RS-232 drivers on the PCB. We were unable to get them properly working. Communication on the board between the Bluetooth module and the microprocessor was actually quite difficult. And so basically, if you look at the system block diagram here, you're going to have the course adjustment instructions coming out via serial to the microprocessor. The GPS and compass readings are coming in, and the course adjustment instructions coming from the PDA right here, and the GPS and compass readings to the PDA. Alright, so this is the PCB. In essence, it should have worked, but unfortunately, there's some issues. One, and this is kind of just a basic problem being amateurs at this, is that the voltage regulator circuit, this was the initial one, was actually...
This, we have two videos. The first one shows that our system functions as expected, which is meant to avoid one obstacle at a time. We decided to avoid one obstacle at a time, as you can see. Okay, so this will keep on avoiding obstacles. The second video that we have actually shows that it worked better than we anticipated, because it can work in a complex obstacle environment and avoid. So there you have it. This is our presentation. We'll just keep on avoiding obstacles now. If you have any questions.